Let's go ahead and summarize all of the transformations to the quadratic parent function. First, let's look at the effect of a coefficient a outside of the parentheses. If a is greater than 1, the graph will be vertically stretched. The parabola will become steeper. If a is between 0 and 1, our parabola will flatten. This is called a vertical compress. A greater than 1 stretch, a between 0 and 1 compress. If the coefficient is negative, and negative outside of the parentheses, then the parabola will be reflected over the x-axis, meaning the parabola will open down. For an h inside the parentheses, the shift is horizontal, left and right. Because we're subtracting h, that movement is in the opposite direction you would expect. If you have x minus h, you'll be moving to the right. If you have x plus h, you'll be moving to the left. For this k value outside of the parentheses, we're shifting the graph up and down, a vertical shift. Plus k is up, minus k is down. Let's identify the transformations for each of these graphs using our understanding summarized above. Okay, first function, a of x equals 3 times x plus 6 squared. First, we have this coefficient a. 3 is bigger than 1, so this is a big A. This is a vertical stretch. The graph is steeper. Vertical stretch. The plus 6 is an h value. It's inside the parentheses. We're moving the graph, therefore, in the opposite direction you would think, left or right. Plus 6 you expect to the right. This is actually a movement to the left, a shift left 6. Next function, c of x equals 1/3 x squared minus 6. 1/3 is a small value of a. It's a value of a between 0 and 1. This is a vertical compress. The graph becomes flatter. Minus 6 is outside of the parentheses. This is a k value, a vertical shift. Since we're subtracting 6, we are moving the graph down 6. Next, b of x. We start with that negative. The negative means we're reflecting the parabola over the x-axis. Is that even English? Reflect. That says reflect over the x-axis. The 3 is large, so we still have our vertical stretch. And then plus 6 outside of the parentheses, we're shifting the graph up 6. Final function, d of x equals negative 1/3 x minus 6 squared. Negative makes the parabola open down. We're reflecting over the x-axis. Is my handwriting getting worse? The 1/3 means we have a vertical compress. Our graph is flatter. And then the minus 6 is a horizontal shift. You expect left, this is right. Right 6. Okay, let's go ahead and use those transformations to identify which graph is a of x, which is b of x, which is c of x, and which is d of x. A of x should have a vertical stretch, and it should be moved to the left 6. Vertical stretch, left 6, that is right here. Left 6, stretch. C of x, vertical compress, and then down 6. Vertical compress, down 6. It's not a really dramatic compress, but it is flatter, so that is C of x. Okay, reflecting over the x-axis, both of the final two graphs are reflected. Vertical stretch, so it needs to be steeper, and up 6. Vertical stretch and up 6, reflected over the x-axis. This is b of x. And then our final function, d of x, hopefully that's this one. Let's see. Reflected, yes. Vertical compress, yes. Right 6. We have successfully used our knowledge of transformations to identify these graphs. Last example, we're just identifying the transformations. We have 4 transformations. For g of x, we have a negative. That means we are reflecting over the x-axis. 8. 8 is big. 8 is bigger than 1. That is a vertical stretch. Vert, stretch. That means steeper. Plus 1, left or right. We expect the positive to move it right. It doesn't. We're moving the graph left 1. And then finally, minus 4. That means we're shifting the graph down 4. This page should seem really familiar, and you should go back and you should look for a very, very similar notes page for absolute value function transformations. You should compare the two pages and look at the similarities to understand the connection between the transformations between the two functions.